Hi, and welcome to the Ntropy custom model tutorial. In this video, we'll walk through the steps required to train, test, and deploy a customized Ntropy transaction classifier. For more details, we hope to check out our blog post where we describe why custom models are needed, how well custom models perform, and finally, and most importantly, how to build an accurate and robust custom model. In this video, we'll focus on brevity and show you how you can quickly build custom models in just a few lines of code. So let's get started. First thing we need to do is run this cell at the very top. The first command installs the Ntropy SDK, which is the Python package used for interacting with the Ntropy API. In the next two lines, we install two datasets containing transactions for training and transactions for testing. These are synthetic, handmade datasets that we prepared specifically for the purpose of this tutorial. They contain about 300 transactions in total. In the next line, we import the Ntropy SDK object as well as the custom transaction classifier object. Since customization makes use of the Ntropy API, we also must include an API key, which we set as an environment variable here. In this step, you'll need to enter in your own key as the one in the tutorial is just a dummy, which will not work for you. In the next cell, we load in the train and test transactions as pandas data frames. Then we instantiate a custom model class. The only argument you'll need to provide is the name of the model, which is used to tell the Ntropy API which model you want to use when classifying. And that's about it. Training is as easy as just running model.fit, supplying the train transactions as well as the train ground truth labels. So while that's running, let's go ahead and take a look at our data. Customization uses all of the same fields as the Ntropy SDK does, with one important exception: ground truth labels. These are the custom labels that we'll use for every transaction. In our example, we have 4 custom labels: food and drink, software, food distributors, and cybersecurity. So now that our demo has finished up, we can go back. One thing to note is that any label that you use that is not in the training set will not appear in predictions, so it can only predict on things that it was trained on. Another thing to note is that in order to get the best performance, we highly recommend that you use at least 16 examples of every custom label that you want. And you can see in the dataset here, we meet the criteria of at least 6 for each one of these. So now that training is done, we can run the model.score method, which will return the accuracy score of the model that we just trained. It takes as inputs the test transactions and test labels. Since this function also requires the API to run, you'll need to make sure that you still have the environment variable for the API key enabled. Optionally, if you don't have a test set, you can run the cross-validation function from scikit-learn, which will give you an estimate of how good your model is using only the training data. So using the test data, we can see that we do pretty well, like 95.5% training after doing customization. For cross-validation, it'll return 5 scores, which indicate on average about how well each one of these does on 5 different subsets of the training. So you can see we get about 93.5, 100, 100, 93%, 96, which is roughly what we see from the holdout test set. So it's pretty accurate. And that's it. You now have a trained custom Ntropy model. There's a few more things you can do. So one is that you can get the labels that you want using the model.predict method, which if we run here, we'll do the same thing as before for model.score, but instead turn the labels predicted. And you can see that they now fall neatly into the hierarchy that we created, or set of labels. And finally, this is the important step for using this in the future. You can integrate this really easily with the Ntropy API. All you need to do is instantiate an SDK object, and then when doing the normal enrichment, you just add one more keyword argument, which is the name of the model that you just trained. And for convenience, I just use the attribute of the already trained model. So we can go ahead and run this. And then while it's running, you can see what the finished result will look like, which is the enriched data frame containing all of the labels that we just put in. And for completeness, we can also show what the model name is, which is the one that we had before. And that's it. So this wraps up the quick start for the Ntropy customization. We hope that this helped clear things up, and we can't wait to see what you build. Thanks for tuning in.